Good evening, everyone, and thank you for joining tonight's webinar. Please be reminded that throughout the meeting. And for questions, please use the questions box. Tonight's speaker is Professor Michio Kimura, professor at the Department of Medical Informatics at Hamamatsu University Hospital. He's part of the IMA board as well as the IHE board. And Professor Kimura is also chair of HL7 Japan and was former president of APAMI. May we now call on Professor Kimura to give his presentation?
Yep. Okay, you're watching my screen, right? I put this thing on, and you are going to watch the. Okay. Hey. The slideshow coming, right? You are watching my screen.
Yes, Professor. Okay. Thank you.
Oh, no. Cancel. So how can I? How can I? You're watching the control panel of the webinar, or you are not just watching my slide screen?
Just your slide.
Oh, good. So how can I make this smaller?
You can click the orange icon to hide the control panel.
Orange icon.
Yes.
Okay, got it. Okay. Good evening, ladies and gentlemen. This is Michio Kimura speaking. Hamamatsu University, Japan, professor of medical informatics and EMEA board member. So I think I did about a 1.5 year ago. At the time, I emphasized on it is HL7 based standardized storage. But at this time, I'm emphasizing on how we can make use of the storage, which is no database engine needed, which is much inexpensive, and we start using for patient information exchange. So we put emphasis on this issue. Okay, the second. Wait. So you are also watching my cursor, right? So please think that this is a storage at the center. It's a electronic medical records. It could be the order entry system or just the document system or something. Usually we put the prescription injection and also the lab results in a HL7 format and store in this center storage, which needs no database engine. And this is a Ministry of Health project of Japan, and it has many advantages, many good use of it, which is it can be used for giving the CD or the network and giving to the patient or the patient data, or sometimes we use this for backup for disaster, or sometimes system failure or system replace blackouts. We don't have at the time we don't have this one, but still we have this one which is browsable, and at least we get the prescription, injection, and lab results and disease classifications. And also recently we are storing many kinds of documents. That's we are now emphasizing on. So also we can make use of the case cards, could be the clinical research or could be some reports or something. The document maker, of course, the content is made at the what professor of the content document maker, but they can get the patient information like the demographics, the ages, the sex, and disease classifications, and lab results, that kind of things, and other documents, other images can be retrieved from the storage, not from the EMR, not from the PAC system. And sometimes we make this for the source of the big data going down for research purposes. Okay, so what's the advantage? I say if some document making system, or could be the or some department system like pharmaceutical department or the dietary department, or could be the operation management department. They, for example, operation management department like to get the lab results of the hepatitis B antibody and antigens. It can be they can ask for the EMR, but EMR is busy and EMR don't want to be annoyed by that kind of things. And we say that, oh, please look at the storage. They are stored in there. So we have less risk of, some, of failure of the EMR operations. Or sometimes we have the blank out for the disaster, or could be the system replaced. We don't have the HIS or EMR at the time. But still, these systems can get that kind of information from the storage. The backup system can just browse the storage, and provided that the network is on and the storage is on, and EMR is out of operation, even in case of out of operation. That's some advantages. So the storage structure, it's something like just a file system directory service. The storage roots, and then the patient ID first 3 digits, 1 out of 1000, then the remaining digits for patient ID again, and the transaction date, and the event message identifier, and the results there. But I say we can make annex storage as the same structure, and we drill down first digits of the patient ID, remaining ID, the dates, and the contents identifier, and we have the JPEG files, CDAs, and Word files of the Excel, CVS, that kind of things. PDFs can be there. So I say the standardized storage, we store HL7 message for the lab results and prescriptions, but annex storage, we can put anything: Words, JPEG, PDF, CDA, even movies. So we don't use the database engine. Just this is a file system service of operating system. People may ask me, it is enough quick? It is enough quick. I'm going to show that on the video or movie later. In our country, we are now, we have 754 hospitals have the storage, which stores the prescription and lab results. And of course, there are many other use of the document storing other purposes. It is as of last year, March, we are going to do the new, this year's survey, may go more hospitals. Actually, let me say, how many hospitals in our country? We have 8,000 hospitals in our country, about 80,000 clinics nationwide, and 8,000 hospitals. So about more than 1/10 has that kind of system, storing many things like the lab results and prescriptions, and some documents and images. How many people covered by this storage nationwide? 754 are storing prescription and lab results, and average hospital, about 250 beds, stores 2 years of data. First year, 20,000 patients, plus every year increase of 7,000. So 2 years storage makes the 754 hospitals. Total is at 20 million. Of course, we have duplications. So maybe it's between 10 million to 50 million. We have 120 million of our population. So it's about 13% of our total population right now. Let me say we have the storage is a little bit biased that most of the hospitals are rather large hospitals, not that small hospitals and no less clinics. But recently, many smaller hospitals like to equip this storage because of many reasons. Later, I say it can be used for big data making. I mean, the clinical case database, big data. The smaller hospitals also like to participate in the big data projects. That's why smaller hospitals are looking at having the SSMIC storage. Ministry projects based on this storage. The first one is Ministry of Health, PDMA. PDMA is a Japanese FDA, Food and Drug Administration. They have the MidNet project, which is drug adverse events early detection. We have 25 hospitals equipped with the storage, also with the search database. They have the special database, and we detect the possible adverse events by a drug every week. That's a new MOH's project. It is, of course, based on this standardized storage. Also, regional healthcare information sharing. Noto, Urasoe, Miyako are the typical region name. Of course, they exchange the lab results and prescriptions, but also referral documents or the discharge summaries are now being exchanged between them. So, of course, it is good for lab results and prescriptions, but also it is good for just the documents, just the images, JPEGs and movies, other kind of many kinds of files, other objects. AMED, it is Japanese NIH. NIH is the National Institute of Health of the United States. They provide research fund for clinical case registry, big data for many subspecialty, like the cardiology, cardiovascular societies. And also, actually, I'm a radiologist, and Japan Association of Radiologists, Clinical Radiology, have that research funds, and they submit the images and also with reports, read the examination reports. Other pathology doctors, I mean the associations, and also the endoscopy associations, diabetes association are research funds awarded by the AMED, and they are making the big data system. And most of the case, they require SSMIC storage and the documents to be stored there to collect. Last one, Ministry of Education. We have 42 national universities nationwide, and they all have the backup of the EMR. So that's a ministry project on SSMIC storage. Of course, other private applications we can find many places. Storage without database engine, it is enough fast? People may ask. Making use of the directory search function of the OS filing system. So the filing system is so optimized with heavy hashing of the, finding the file name and the directory name. So it is enough fast. And the first 3 digits patient ID, the sub goal is 1 out of 1,000. It's a good sub goal, moderate sub goal, and followed by the remaining digits and the dates. But let me say, if you like to have the certain patient lab results, it's great, enough fast. But if you like to have the list of the certain drug takers, of the certain examination, high value patients, please buy relational database systems. So it's not the directory, or direction, hierarchy direction. If you like to have a certain patient lab results, prescriptions, it's enough fast. of course, certain patients' documents also. But horizontal, thorough search. That's how DBMS is good for that. So, for the purpose of the, certain patient, it's good, and for certain patients' images and documents to be exchanged, it's good. That's limitations of the storage. For patient information sharing between hospitals, could be clinics, use cases, something like that. Collect certain patient records and then send. Don't like to connect to other hospital system. You may not like to fully connect to other hospital system with intervention to the database engine of the EMR. But by using the storage, you can say, you can see the storage, not me, not EMR. We put the documents and some needed information in the storage, not our very heavily used EMR. But you can see that. That's a use case of the patient information sharing between hospitals. Of course, it's great for disaster backup. Actually, many clinics of the northeast side of the coastal Japan, which was hit by tsunami, and there's a resilience fund from the ministry, and they raised hand. Many clinics and small hospitals having their backup using this storage. So you are going to see the backup PC video. Let me say, there's 25 sets in my Hamamatsu University Hospital, which have SSMIC storage, and also the documents of the patient records. And you are going to see the real-time retrieving speeds. Actually, the PC itself is just a Core i5 kind of very moderate PCs, which has the 10 years of old storage, which is a prescriptions, lab results, and related documents of the patient records of the total 300,000 patients. So I think the movie time. Oh, movie time. This one. You're watching the movie, right? Awkwardly or smoothly? Is that okay for all of you? So it's my hospital machine room. Is that okay? You're watching that? It's a highly secure room in the machine room. I'm greeting you. And we have 25 PCs with all of them with the storage of the 10 years lab result prescriptions and some, medical records documents. And in case of the disaster and the system failure, even the network failure, we put that set one PC and one external hard disk to each ward and the clinic of the hospital. And we show that. And we put the patient ID here. Actually, it's coming out. This is actually my name, me as a patient. And we are watching, I'm sorry, it's a Japanese language. It's disease classifications, prescription history, and lab result. Put the prescription history, and we get the prescription history there. There are many prescription histories are shown. And also, please look at the lab results. Lab results coming like that, 10 years or more of my lab results. This speed, enough fast for the disaster backup and maybe some, retrieval kind of use. Second one, documents. It's a medical chart stored in the medical record, sometimes as an image format, sometimes in a, just a Word documents. It's an image. Actually, it is the, encounter nodes that I hit my hip and some paralysis there. Actually, I had it in February, and they had it, so they recorded it. And this is my, renal tract stone. TUV images and also the reports there. Like that. The medical documents are also stored there, and we can see this speed, enough speed, I think. And also we have some small PAC system in the PC, because the PAC system images examinations are so large, and we only have the 3 months of it. As I said, I just had fallen, from the hit from the back, and the neck was a little bit paralysis on my fingers. The spinal cord is a little bit, pushed by the disc, which made me some paralysis on my fingers. It's an MRI taken. And of course, you can see the reports, MRI reports like that. It's something like the central nerve, C4, C5 level pushed disc spinal cord. That's the way we do. I believe you enjoyed the speedness of how fast was the only the directory style storage. Even without HL7 exports out of hospital information system, you can make use of this storage, storing the documents. So just the same structures, first 3 digit, second 3 digit, total digits, dates, and what's the content, clinic referral documents. Actually it's a LOINC code. Worldwide standardized LOINC code for referral documents, 57133-1. And the date and some contents ID folder name, and then the referral documents there. Could be Word file, could be PDF, could be CDA, could even with JPEG or even the movie. So I recommend you to use this storage, even if you don't have the HL7 exports. You just put your documents there, any kinds, and let other hospitals see that, speak that. And it's a good, you don't have the database engine for the view outside. Document code, let me say, LOINC. LOINC is a logical observation identifier names and codes made by, born in Indiana University, 1994, Professor Clem MacDonald, now half retired, but just retired from the NLM, National Library of Medicine Director. And the Indiana University made the LOINC code, and there's now maintained by the LOINC Consortium. Freely available. Recommended at the meaningful use of United States, and it is eligible for United States premium payment. So LOINC codes are widely used in the United States right now. First was for the clinical lab results code items. Then they started to include some clinical observations like the blood pressure, systolic, the diastolic, or other pulse or other findings. Now they are also available in the documents. What kind of documents? Could be a referral documents, could be the discharge summary, or the diagnosis certification, or many other kind of things. So in Hamamatsu University, we may have the clinical referral local code 01234, but at the same time, the second repeat of the code identifier, we use 18842-5. It's for referral documents at the standardized LOINC codes. First repeat could be the local code. Second repeat should be standardized, so we can the receiving side can see what's inside by looking at the standardized codes. It's a recommended use of the document labeling. Loin codes like this, I'm sorry, again, Japanese code tables. Most generic things, I say this is instruction documents, certificates, and opinion documents, confirmation documents, and consent form. Of course, we have many consent form for operation. They have loin codes, concentration, and a consent form for anesthesia. It has a cause. But other kinds of many kinds of consent form, we use this generic consent consent form code, and we request that kind of blank area from Japan. We requested the LOINC consortium for issuing the LOINC codes for like the blood transfusion consent form, or the chemotherapy for oncology consent form, many kinds of maybe specific, but coming rather generic kind of documents. So it's an open software. We can give it all with English manuals, storage software included for prescription lab result, and also the annex for documents, archiver and viewer. And of course, they need the hardware, blade server, installation cost, and some tests. So ask our association, Japan Association for Medical Informatics, jami.jp, English page. They have the SS Mix maintenance. They are doing the SS Mix software and the specification maintenance. So ask Jami or ask me for the specifications, and of course we can give you the storage software itself. We are now trying to make the SS Mix storage specification for ISO technical specifications. It is supported by the ministries. Ministry of Industry is now supporting us to make SS Mix specification for ISO TC215 health informatics technical specifications. So JICA, I don't know what's the abbreviation, but Japanese, I'm not sure. But anything. Anyway, it's a Japanese overseas support project. Says yes to SSMX-based implementation project because it is so inexpensive. And JICA says, oh, it's a good one and inexpensive one. So we're going to ask the applicants for thinking of the SSMX storage for without database inexpensive way of storage and for the patient information exchange. So JICA is very happy to hear that. And of course, JICA is very happy to hear that it is becoming an ISO specifications, international standard specifications. So it's the end of the presentations. And again, I'm greeting you by my picture. Any questions can be aimed to me. And it's 30 minutes. And that's it for the presentations. Any questions? This one?
Yes, thank you, Professor. Our first question is, what do you mean by no DB engine? Is it just a text file?
No. Oh, you don't have to buy a database engine like Oracle that informatics, that kind of things. You only have to have the storage specifications to store and retrieve the information. So the contents could be Word documents, contents could be PDF, JPEG images, anything. So no database engine means you don't have to buy Oracle, the kind of database management systems. Is okay?
Yes, thank you, Professor. Let me just check the next question.
I'm looking at the questions.
Yes, and how do you constrain access privileges to the SSMix storage?
Access control?
Privileges to the
You're asking that?
Yes.
it is out of the specifications. So you can use, or secure software or the secure routers, that kind of things, for each suitable for each use cases. So it is just the specifications. If you like to make the access control, you are going to have that kind of software, access control software. So it's just a So in that case, in that meaning, it is not fully substitutes the database engine, because database engine has access control, but it's a specification itself. So access control can be out. It is out of the specification of the system routers. So please buy yours suitable for your case.
Okay, thank you, Professor. The next question is, why did you choose SS Mix over current standards such as HL7 Fire?
HL7 Fire, of course, let me say, HL7 and version 2 series lab results and specifications, it is in some HL7 Fire use case, you can put and get the lab results and prescriptions in this storage. So then HL7 Fire is something like the use case based for the regional information sharing. So as a source of the database, you can use this storage without paying the Oracle. So if your HL7 Fire use case needs the lab results or the documents, get that from the storage. So Fire is not the database structure, specifications, any kind of that. Fire is something like the exchange, or agreements or something like that. So if you have some ingredients of SSMix storage for your HL7 Fire use case, please use that. Please put that things. Please get them out of it. That's my answer to the conformant to HL7 Fire.
All right. The next question, Professor. Is the data encrypted?
Oh, you can encrypt. You may not encrypt, or you can encrypt. So as a PDF file, you can encrypt. Word file, you can encrypt. So it's not our business, not the storage business. It's applications business. Okay.
All right. So, the next question. Yes, Professor, do you have something to say?
Again, I'm saying that if you like to encrypt it, you encrypt it and then store. So if you like to get the access control, you get the access control, and anyone permitted by that, she can get there. That's the way we do. Very simple. Only the core thing we propose. Of course, database engines, Oracle is offering more gadgets and the access control, that kind of things. But we are just proposing the core of the data storage.
Yes, thank you. The next question is, what operating system is the system using? Is it Linux? And how do you handle users and file directory permissions?
Okay, so Linux, or could be the SQL server. It can be it can use that storage structure. So at the access control or the data getting and getting out, actually we use a SQL server most of the case, but you can use your Linux. So don't have to be. That's just the storage structure.
All right. Our next question is, what is the file service system? What does it mean?
What are there? What is that?
File service system. What does the file server system mean?
Oh, it is a file system itself. So if you have the Windows 10 on PC, you have the file system, you have the document, and you have your computer directory there, C drive, and the directories. That's the same thing. So it is, or it can be used under any, operation system, filing system. Then you are going into the SSMIC storage as a, more precise definition, hierarchy of the filing system. Anything, or Windows 10, or could be other, or larger computer operating system, or could be the Linux or Unix, anything.
All right, thank you, Professor. Our next question is, do you store only documents, and how can you go over such data with a big data approach?
Oh, actually, every hospital who participates in the big data collection system, collection project, they have the SSMIC storage. They have the EMR there. EMR is exporting the lab results and prescriptions, and also the documents, maybe the case cards, or could be the reports of the image examinations. They are stored. So now you have the SSMIC storage. The software to collect that is easily installable. We have many things. Just a browser and plus some, applications. They get a case card, lab results, prescriptions, and documents, records. And as one whole, case card could be, zip filed, most of the case. Then they send to the, project servers of the, maybe each hosting institutes. Like the La George Society, in case, I believe it's in Kyushu University, they are collecting the large images with lab results. Anyway, I say if lab results, prescriptions, images, documents are in the storage, the big data project sends each hospital to collect one patient's, big data things, and they submit them for a case big data case database. So every hospital can use the same software because they have the same structured SSMIC storage. That's a good thing to get the big data from many hospitals and clinics. Okay.
All right, the next one is interesting use cases. I agree that HL7 will work well for cases like these that store granular data. You mentioned that it is being used for disease registries. How do you extract the fields and mask from the data fields in the messages?
I already answered. Or in each hospital, they have the storage. So the software given from the project leader application, they get the lab results, patient demographics, and also the images could be, the reports and the summaries could be, and maybe the application make it in one file and send it to the project leader servers. How it is encrypted, or how it is safely, or how it is automated, not a fully automated stream to the research site. But in our country, patients are not happy with automatic data collection being their patient data being used for other purposes. So actually one-time manual. So some hospitals connect their system to internet. Some others don't, like us. Actually, in our case, we collect the data in a hard disk portable hard disk, and then we unplug that and plug to the internet uploading PC, and then upload it. So my Hamamatsu University Hospital is EMR is not connected to internet, but we cross the river. You understand this expression, cross the river, to enhance the safety. It could be connected, or it could be manually cross the river style of security. That's the way we do for collection of the large database.
All right, our next question, Professor. How different is this to Linux file system structure or the Linux directory structure?
Same, because Linux is a Unix file system structure, and it is like that. So it is the same, like others of Windows 10 or same.
Yes, thank you. Next question is, I saw the radiologic images attached to the patient file. Did you wrap it inside a DICOM layer? If not, how is the patient metadata handled?
You mean you have seen the images as a DICOM file, right? And the question is, I'm watching the question. Which one?
Did you wrap it inside the DICOM layer? And if not, how is the patient metadata handled?
Okay. Now DICOM has specification for anonymizing the patient demographics. So if the PAC system is able to confirm the DICOM anonymization, the patient name and IDs, that kind of things are blanked. So and with the DICOM service of the PDI is IHE PDI, which is storage, and I'm not sure. It's a external media storage in specifications, which is a package of the usual CD, CD documents, CD images of DICOM and DICOM directories. They pack it, and if the PAC system is able to anonymize the patient demographics, the name is anonymized. So it's all up to the application requirements. And of course, you can put the DICOM image at the annex storage. It is with patient demographics of the name, or the age, or the sex, or that kind of things. And of course, you can put just a JPEG file for that. It's all up to your use case. Okay.
Thank you, Professor. The next one is another standard health data storage approach or solution used in the rest of the country, or is it a range of other approaches?
If you think of one project going to collect the information directly from each EMR, the query and retrieve messages between the database engine must be installed. The database engine could be one side is Oracle, one side is just Linux. So, or you had to make the many pairing of the application query and retrieve messages requests. So, but think that we have the same structure. The Linux can put that one. Then maybe other data collection site maybe using the Oracle, but data access is just to the storage. So it is somewhat standardized. So you don't have to make the full pair combinations of the databases of many kinds. That's an advantage of just a common thing, core storages for to send message between database systems. Okay.
Professor, I think this is a clarification on the question. If SS mix is used in 10% of Japan, what is used in the other 90% of the country?
Most of the 90% is just small. So EMR installation rate in our country of the hospitals of the 8,000, it is about, I think, 40 to 50. So other remaining 50s are just making order entry, or could be, or just doing the paper-based. Most of the smaller hospitals. Larger hospitals, more than 400 beds, they use EMR rate about 85 to 90. So they are, let me say, waiting for the next, system upgrades. Most of the case, because many subspecial medical professional societies are requiring SS mix storage-based data collection. There are many doctors are requiring the hospital headquarters to think of installing SS mix storage next time we change the system. So that's why the number of the SS mix installation is going up. Used to be 300, now 500 something, 700, now more than 1,000. So the ceiling could be about 3,000 or something, because 3,000 is the number of the larger hospitals. Smaller hospitals, they still use the paper-based or just some very, very light EMR, and they even don't handle the lab results on their table PC. So that's why the answer is because they are small. Because they are less motivated to participate in the or data collection. But again, let me say, in Tohoku area, northeastern area, they are happy to have their smaller clinics management system backed up in the database service, remote database service system, service provider, for fear of another tsunami come for the disaster. So that's a resilience project. Subsidy money came from the ministry, so they raised hand to have their system backed up by SS mix storage formats. Okay.
Thank you, Professor. The next question is, how do you perform audit trail and historical data on this file system structure?
Oh, good. Audit trail. We actually, I didn't mention that it is SS mix version 2 right now. Version 1 is a very big plain one, but version 2 have the transaction file, or the management footprint file, audit files. So actually, they make the audit files. If the request side, the request software provides or username, or maybe the routing PC network routing specifications, the audit files are made. If they like to use it, they have the specification for that in SS mix version 2 right now, the latest version. Okay.
Thank you, Professor. We have another question. If the system of a small hospital fails, how long would it take for the files to take the files back, or it can work immediately?
You mean if installed, it can be immediately used, or you have to wait for that? You mean?
I think if the system in a small hospital fails, how long will it take for the data to be retrieved? Or can it work immediately?
You mean political questions? If political questions, it is a political questions. We are our medical providing services are fee for service, and the tariff is made by the ministry. And the ministry now sets some premium money for network-based data transfer at the referral, about $20. But to qualify for the money, they had to have the storage. So Ministry of Health is backing up a project. And also, let me say, NEC, SBS software are new EMR. They provide SSMIC storage once set freely. It's not optional. It is coming with the EMR system itself. So the number is getting high and high. And because of the research projects requirements, or also the ministry reimbursement system, fish hook. So many EMR vendors are now looking at proposing the hospitals. Oh, it is cheap, and you may make use of this one for disaster, or could be the data submission, or could be the data sharing between the hospitals. So we are very much looking forward to seeing the number growing. Okay.
All right. The next question is, can the file system be accessed through a browser like documents accessed in Apache server?
You have seen that, the video. I just use the browser software to look at my, lab results and prescriptions. You just watched. So only the browser can get information. It is good for disaster, you see. No database engine, but still only the network and browser at the PC, you can see that. And you can continue the medical practice even without, or even when the EMR system failure. You have seen that.
Next question, Professor. Is the plan to leverage SSMix to make a national EHR for all Japanese citizens?
No. It's just a storage. So EMR itself could be provided by Fujitsu, NEC, other, or domestic vendors. But it's just a, function to exchange data or store data for disaster. Just a function, not the EMR itself. If, as in the presentation, I said, if you like to see the one patient results and prescriptions, it's good. It works. SSMix works in a very fast speed. But if you like to do the horizontal search, any patient who have taken this medicine, that kind of things, or other order entry, or services, I think you have to buy the RDBMS, not SSMix storage only. Only the SSMix storage can't provide that many, service functions for EMR.
Professor, I think the question earlier is referring to shared health record, not a local EMR, EHR, national EHR for all Japanese citizens.
National EHR. Anyway, if we have the national EHR, I think it is going to be based on the storage data, because hospitals are not comfortable with when their EMR is directly connected to other rival hospitals. So I said, you can see that. Please pick that one. Get the data out of it, not our EMR itself. It's a national feeling of each hospital in our country. We are not Northern European, healthcare provider. We are not in the UK model of the NHS, who provides the EMR system from the ministry. We are not doing that way. Each private sectors are buying their suitable EMR. So to make a nationwide EHR, I think SSMix storage is going to be the sharing data infrastructure. Okay.
Thank you, Professor. Our next question is SSMix used for transactional-based or analytics-based storage? OLAP versus
Yes.
OLTP?
RDBMS is full service expensive ones, and standard structured and also the annex structured is a very inexpensive one. So I already explained how it is useful for case card making, making the case card document itself, and some log results and other images can be collected from the storage. It's easy to do that, and the software is standardized. I mean, even if they have the Fujitsu EMR, NEC EMR, IBM Japan EMR, we don't care, provided that they put that kind of common data in their standardized storage. Same application of making the case card can be used everywhere. That's a good one. Okay.
All right. Our next question is: does SSMix handle indexing of common data fields across discrete patient files?
Common index? You mean common index is a common patient ID? You mean?
Indexing of common data fields.
Indexing the common data fields. Maybe it's a basic EMR demographics, right? Basic thing is coming from the EMR. Patient name, ID of the hospital, ID of the region, could be ID of the national, and the age and sex and other specifications. The demographics are coming from the EMR. If you send that. Okay.
Thank you, Professor. I think we're down to our last question. Dr. Fazila, would you like to ask your question?
Yes. Hi, Prof. Kimura. Can you hear me?
Yes. Oh, sure.
Yes.
Very clearly.
Yeah. Are all the hospitals mandated to send data to this EHR? Is it a policy?
It's not a mandation, but they are leading to that by making some premium of the payment. And also, for the hospital, it is not mandated, but for the motivation for each hospital, one is participation. One is getting the premium money when sending the referral document with data.
Oh, okay.
SSMix storage equipment is needed. Second is academic research, project participation. A third one, maybe I think it's a disaster backup. I think in our country, it is not mandated, but it is recommended.
Recommended. Okay. Is this the only single EHR storage in the country, or you have multiple?
I feel no competitor.
Okay.
No competitor, because it is very expensive, very plain, and so you have seen that more than 1,000 hospitals are being equipped. It's almost 1/8 and half of the large hospitals.
Yes.
And the number is growing.
All right. But what about, do you have primary care in Japan? The smaller clinics? Of course, yes. Did they also send the information?
Let me again say, small clinics have less percentage of EMR, about 35 to 40. But again, I say the northeastern area, they have been their system washed up by the tsunami, and they are happy to raise their hand to get their system backed up by SSMix storage format. So they are doing that.
Thank you.
Thank you.
And is there any other questions?
Let me say, for the regional care and the primary care, not prescriptions and the lab results are not exchanged, but documents of some, care direction reports or the care, home care. Home care reports or home care directions, that kind of documents can be exchanged by that. So Ministry is now interested in having using that inexpensive kind of things for the basis of the home care
right.
supervised by the hospitals. And it's something like the small regional data exchange, not the system connection, but storage peaking for exchange of the documents.
Okay, thank you.
And JICA is happy to subside the SSMix-based projects, and we are happy to provide the English version of the specifications. Please ask me or please ask Jamie. I'm very happy to.
Yes, we will. Is there any more questions, John? Anyone else?
There are no more questions, Dr. Fazila.
Oh, okay. Prof. Kimura, I'm Fazila from, on behalf of AeHIN, I would like to thank you for giving us this talk on the AeHIN Hour. So we wish you all the best, and hope you will further succeed on this nationwide EHR storage for Japan.
Thank you very much.
Thank you. Thank you again. All right. Have a good night. Good night, everyone.
Good night.
Good night.
Good night. Thank you very much.
Bye.
Good night.